Hello students, today in this lecture we will discuss about different types of feed mechanism. So to understand different feed mechanism, first of all let us understand what is the meaning of feed. So the feed is nothing but the relative movement of the tool with workpiece is called as the feed, and there are different variations or types of movements are available for the tool. That movement may be, first one is it may be a longitudinal movement, it may be a crosswise movement, or it may be a angular movement. So there are different variations of movement required for different machining operations to be performed on the workpiece. So the first one, that is the longitudinal movement, is given to the workpiece, or the longitudinal movement is given to the tool by using the carriage. Another one, that is the crosswise movement, or the movement perpendicular to the workpiece, is given to the tool by using the cross slide or the feed screw. Similarly, the angular movement to the workpiece is given by using the another important part that we have discussed, that is the swelling plate that is attached to the compound rest screw. So there are three different movements. Most important, first one is the longitudinal movement, second one is crosswise movement, and the third one is the angular movement. And there are three different parts are available to obtain these three different movements and provide this movement to the tool. And all these different movements can also be obtained automatically by using different mechanisms, because in our previous lectures we have discussed that these different movements are given to the tool by using the different types of wheels or by using the hand. But these all movements can be given automatically to the tool also by using different types of mechanism, and that all mechanisms are nothing but the feed mechanisms. So the different types of feed mechanisms available are, the first one is the tumbler gear mechanism, second one is feed gearbox, third one that is the feed rod and the lead screw, and the fourth one is the apron mechanism. So from all these four, the first one, that is the tumbler gear mechanism, and the last one, that is the apron mechanism, these are the main two most important mechanisms which are helpful to provide automated movement to the tool for machining operation. Now let us understand the first one, that is the tumbler gear mechanism. So first of all, what is tumbler gear mechanism and where this particular mechanism is available in the lathe machine? So for this, have a look at this particular figure, and here take a look at this particular portion. So this entire section shown over here, that is nothing but the headstock. And at the end of the headstock or behind of that particular headstock, this entire gear assembly is available. And this available gear assembly is nothing but the tumbler gear mechanism. So this tumbler gear mechanism is available at the back end of the headstock. Now to understand how this mechanism operates, let us have a look at different types of gears available in this particular machine. So here, from this particular portion, this section is nothing but the end of the spindle. So as we know, power is transmitted to the spindle, and spindle is connected to the workpiece, and that is how workpiece is revolving about its axis. So here at the end of the spindle, one gear is attached, and this gear is also rotating with the movement or with the rotation of the motor provided at that particular point. So in normal condition, below all gears are in disengaged condition. During normal machining operation, there is no connection between the end gear available over here and the below available gears, and that's why it is normally automatically rotating, and there is no movement in below available gears. So now let us draw the simple 2D figure of these all gears and show the connections, how this particular mechanism rotates and how the motion is transmitted from the spindle portion to the final available sections. So for that, let us have a look at this simple 2D figure of the tumbler gear mechanism, and we will give the name to these all particular different gears. So the first one, that is, let us say, as this is the gear A, so this is the gear A. Similarly, at this point, two gears are available, gear B and gear C. So these are the gear B and gear C. Here one lever is provided for engagement and disengagement purpose. Similarly, here lever is provided. Similarly, as you can see, at the back end another gear is available, and this gear is called as gear D. And as there are two gears are available on the same shaft, so the another outer gear, let us name it as gear E. So here outer gear, that is the gear E. With this outer gear E, another gear is connected, and let us give it name as gear F. So overall, this is the gear F. Similarly, at this end portion, the last gear connected to the F, that is gear G. So this gear, let us name it as gear G. And this gear G is connected to the lead screw or maybe feed rod. So the rotation of gear G automatically result into the automatic rotation of the lead screw or the feed rod. So from main spindle portion to the lead screw or the feed rod, the automated movement is given using this all entire gear assembly. Here these two disengaged gear B and gear C are useful for engaging and disengaging condition, and that's why this gear B and C, these two gears are called as the tumbler gears. So these gear B and C are useful, that's why these are called as the tumbler gear, and this entire mechanism is called as the tumbler gear mechanism. So how this motion is transmitted? So for that, let us have a look over this portion. Here, as we say, as the rotation of the workpiece is given in clockwise direction, that means when the gear A, which is connected in the clockwise direction, as it rotates in the clockwise direction, this entire movement or rotation result into the clockwise movement, and this clockwise movement result into the movement of the workpiece in clockwise direction. But here, as you can see, this gear B and gear C are in disengaged condition. That means the motion from gear A cannot be transmitted to the below available gears. So to transmit the motion, this lever is shifted in downward direction, which result into the connection of gear B to the gear A. And that is how the another connection is obtained between all these gear, which is shown in this particular figure. So again, let us name it. This is the gear A. Now after applying the lever, what happens? This gear B connects the gear A and the gear C. The another gear, that is the gear D, E, F and G. Now again, let us say if the gear A is rotating in clockwise direction, so this gear B starts rotating in anti-clockwise direction. Again, B and C are connected, that means this gear C rotates in clockwise direction. As gear C rotates in clockwise direction, gear D rotates in anti-clockwise direction. And gear D and gear E both are available on the same shaft, that means that both are rotate in the similar direction. That means gear E will also rotate in anti-clockwise direction. Now gear E and F are connected, that means gear F will rotate in clockwise direction. And as F rotate in clockwise direction, this gear G will rotate in anti-clockwise direction. That means this last gear will rotate in anti-clockwise direction, and with this last gear, lead screw or feed rod both are connected. That means this anti-clockwise movement of this particular last gear result into the automated movement of the carriage from the headstock towards the tailstock direction. So the movement of the carriage from headstock to the tailstock direction automatically is obtained by connecting these particular tumbler gears with the main gear connected to the spindle. So if we see from here, if the connection is like that, A, B, C, D, E, F and G, at that time what happens? Headstock towards the tailstock direction carriage movement happens. But when, if the connection is reverses, that means if C and B are connected, and in this particular portion what happens, the final movement or the direction of the movement reverses. So that is how the movement of the carriage from headstock towards the tailstock or tailstock towards the headstock automatically obtained by using this tumbler gear mechanism. So this tumbler gear mechanism is helpful to provide automated movement of the tool during machining operation. So I hope you got the clarity about how this particular tumbler gear mechanism operates. Now other than these, different parts available at the headstock sections are the first one, that is the feed gear box. So this feed gear box is helpful, or it is useful to obtain a different speed variation during machining operation, and it is also called as the quick change gear box. Now the main operation of this feed gearbox is to provide the variation in the speed during the thread cutting operation. Now the next one, that is the feed rod, and this feed rod is the long shaft which is useful to provide the automated movement or the transfer the movement to the tool using the carriage cross slide section. So here, as you can read from this particular section, this feed rod is a long shaft which is used to move the carriage or cross slide for operations such as turning, boring, facing, etc. But this feed rod is not helpful for thread cutting operation. For thread cutting operation, lead screw is used. And here the power is transmitted from the lathe spindle to the apron gears and through a feed rod and number of gears. Now the next one, that is the lead screw. This lead screw is a threaded rod, and it is used as a master screw and is only required or is only helpful during the thread cutting operation. Other than thread cutting operation, this particular lead screw remains in the disengaged condition. So these are the different important parts available for the feed movement or the feed provision of the tool during machining operation. So in this lecture, we have discussed about the major important feed mechanism, that is the tumbler gear mechanism. And what is the meaning of feed, that you need to keep in mind, because this is the most important parameter to understand what is the meaning of the feed. Again, I am repeating, feed is nothing but the relative movement of the tool towards the workpiece. So I hope you got the clarity about the different feed mechanism and what are the meaning of the different parts that we have discussed in this particular lecture. So looking forward to see you all in our next lecture. Up to then, thank you.